everyone, and welcome back to the Amantya podcast series. I'm your host, Rohina, and today we're talking about something that's quietly reshaping industries around us: embedded physical AI. We're moving beyond AI that lives in the cloud into intelligence built directly into devices, machines, sensors, and vehicles, enabling real time decision making right at the edge. But what does it actually take to bring intelligence into physical devices? To break this down for us, joining me today is someone who's been working in this space hands on. Harinder Kumar is Amantya's VP of Engineering with deep expertise in edge AI, embedded systems, and hardware software co design. And he's here today to help us understand where embedded physical AI stands and where it's headed next. Welcome, Harinder. Wonderful to have you on the show.
Thank you, Rohina.
So, shall we get started?
Sure, definitely.
Embedded physical AI is getting a lot of attention these days. How would you define it? And why is it so critical for the industry these days? As in, why does it matter that intelligence is physically embedded in a device rather than running remotely in the cloud?
Okay, so to briefly define the embedded physical AI, I would say it is when the inference and increasingly part of the learning loop runs directly on the silicon, on the device, and not on the cloud round trip, right? So we are talking about NPUs, DSPs, AI accelerators sitting by the side of sensors, executing quantized models in milliseconds on the silicon itself. Okay. So why it matters comes down to four hard constraints the cloud can't simply meet. One is latency, a lane departure or a safety interlock decision has a 10 millisecond budget, not 300 millisecond. So the decision has to be quick and on the device itself. Second is bandwidth. You can't simply stream 4K video from thousands of endpoints. The economics doesn't scale up, right? Third, privacy and sovereignty. In healthcare, surveillance, and industrial settings, the data can't simply leave the premise. All the decisions are to be made within the premise, and only important statistics can probably be moved to the cloud. Okay, and the fourth reason would be reliability and autonomy. The device can't stop functioning when the network breaks, when it can't reach the cloud, right? So these are the four main key reasons we should talk about physical AI and why the embedded physical AI matters.
Amantya has been building in this space for a while now. Can you walk us through what the work actually looks like and where does the team's edge come from?
Definitely. Uh, so our work mainly sits at the intersection of three key disciplines that rarely live under one roof: wireless and connectivity, embedded systems engineering, and applied AI. That's where our edge comes from because embedded physical AI is a co engineering discipline and not an isolated effort. Concretely, two examples. We have built a video analytics that runs on the NPU of a battery powered streaming camera. Surveillance, uh, lane detection, uh, license plate recognition, safety detection, and action recognition, all executing on device without cloud dependency. Hitting that on a battery envelope means we own the full stack. That essentially means we take care of the model uh, architecture selection, int 8 quantization, NPU kernel tuning as required, sensor pipeline, and wireless layer that streams only what matters. The second is the IoT analytics running directly on the NPU itself, uh, uh, allowing the predictive actions to be taken the instant a signature is detected in the data without the telemetry round trip or the dependency on a cloud rule engine. So the edge isn't any of these skills in isolation. It is the ability to compress a model, fit it to a specific accelerator, and ship it inside a power constrained, network constrained, and a certification focused product.
That's some great work being done, Samantha.
Indeed.
Yeah. So moving on, where where is embedded physical AI seeing the most action, real world action currently, and what industries or applications are seeing the most action right now?
Okay. So I would say there are four verticals that are pulling hardest right now. The smart infrastructure and surveillance is the most mature. Battery powered and PoE cameras doing on device person, vehicle, license plate, and behavior predictions. This is exactly the workload that we run on NPU in our smart streaming camera platform. The moment you push analytics to the edge, the bandwidth cost collapses and the latency drops into the sub 100 milliseconds range. Industrial IoT and predictive maintenance is the second wave, I would say. Rather than streaming current, thermal, and vibration data to the central server, the NPU on the device flags anomalies and triggers preventive actions in real time. That's the IoT analytics use case we have been building. The device now acts, not just reports. Automotive ADAS is the third: lane monitoring, attention detection, action prediction. All of these have to run locally for safety reasons. Uh, uh, Mobility, robotics, and drone, all of them share the same constraints. And the fourth is medical and point of care devices, where the on device inference is becoming a regulatory requirement, not just a performance bottleneck.
That's a lot of traction. um, but everything comes with its own set of challenges. So when building AI into physical devices comes with some real constraints: power, latency, memory, safety, compliance. What are the toughest engineering challenges your team faces, and how do you go about solving them?
So the four constraints that you named, power, latency, memory, and safety, aren't independent. Uh, if you go about solving one, that takes it all on the other. So and that's the real engineering problem. Take our battery powered camera, for instance, which we talked about earlier too. Running multiple analytics like lane detection, license plate recognition, action prediction on a single NPU with a battery budget means you cannot deploy stock YOLO models on it, right? So we approach it on three fronts. On the model side, int 8 and sometimes int 4 quantization, structured pruning, um, knowledge distillation into smaller backbones, and hardware aware neural architecture search so that the model matches the accelerator's instruction sets. On runtime side, NPU kernel optimization, operator fusion, and intelligent duty cycling so that the silicon only wakes when video or audio triggers a region of interest. On the system side, model partitioning between NPU, CPU, and DSP, uh, so that each workload runs on the cheapest compute that can handle it.
So before we wrap up, Harinder, my last question to you. Where do you see embedded physical AI heading over the next few years? And how is Amantya preparing for this future?
Okay. Three shifts over the next 2 to 3 years, or probably earlier. First, the silicon curve. Edge NPUs are moving from 1 to 2 tops to 10 to 40 tops range within single digit watt envelopes. That unlocks transformer class models, vision language, multimodal perception, small language models running on the device natively that used to run only the CNN by now. Second, the workload shifts from perception to action. Today's Edge AI mostly classifies and detects. The next wave is agentic. The device uh, perceives, reasons over a short horizon, and acts. Our IoT analytics work is already moving in that direction. The NPU not only signals the anomaly, it also suggests the preventive action. Third is on device adaptation, federated learning, and lightweight fine tuning on the device will allow a fleet of cameras and sensors uh, specialize in their environment without ever sending the raw data back. So Amantya is gearing up by investing in three things: deeper silicon partnerships. So we have early access to next generation NPUs, a hardened model optimization pipeline that's becoming a reusable asset across the customers, and vertical reference platforms like camera, IoT gateway, and autonomous vehicles. So we can compress time to deployment for the customers building on top of us.
Okay, that sounds very exciting.
Yeah.
Thank you so much, Harinder, for joining us today. Very, very interesting and insightful session.
Thank you, and thanks for the opportunity to talk about embedded physical AI.
Thank you.
Thank you
Look
so
forward
much.
to continued good work from Amantya in the domain.
Thank you so much.
Thank you. And with that, we wrap up today's episode of Amantya podcast series. Thank you for tuning in. We hope you enjoyed today's discussion. Do follow us for more insights on the future of telecom, AI, and digital tech. We'll be back soon with another interesting topic in conversation. Until then, this is Rohina signing off. Bye bye.